Okay, so to begin this video, what we have here is a quadratic function. Okay, it's a quadratic equation that you can graph called with the equation y equals x plus 1, the quantity squared minus 3. And I'm asking you to find the zeros. Now recall what zeros mean. Zeros for our class are x-intercepts, where the graph, the points, the values of x, where the graph crosses the x-axis. So pause your video right now and try to find those values of x. All right, I have a couple choices. I mean, if I have all the technology at my disposal, I guess I could graph it and see the values of x where this function crosses the x-axis. And so I did that. I graphed it in Desmos, and I can see these two spots right here. Looks like negative 2.732 and 0.732. So it seems like the x value of negative 2.732 and x equals 0.732. These two values, okay? But the problem is that's not equals, that's squiggle equals. Those are approximate from Desmos. If I want the exact values where they cross, I have to use algebra. And if I want to use algebra, that means I'm looking for the points where the graph crosses the x-axis. I'm looking for the values of x where y equals 0. So I'm going to substitute y equals 0 into the equation, and this is what we call a quadratic equation. Now you should know that because according to our polynomial work, we know that the highest power on x here is squared, and so therefore this should be a quadratic polynomial. And we're trying to solve it as an equation set equal to 0, all right? So what some students will do here to solve it is they will employ their expansion techniques and hopefully keep kittens alive. And then we'll go ahead and multiply that all out and keep it equal to 0 and see what happens, okay? So that's one option. Expand. Keep kittens alive. It's x plus 1 times x plus 1, and then that minus 3. So that is not x squared plus 1, not at all. It comes out x squared plus 2x plus 1 minus 3. And so I've got x squared plus 2x minus 2. And that also looks like a quadratic equation, maybe more than the original one looked like. And you might try to solve it by factoring like we did today. However, there are no two numbers that are rational numbers that multiply to give you negative 2 and add to give you 2. Go ahead and go all day long. The only numbers that multiply to give you negative 2 are negative 1 and 2 and positive 1 and negative 2 as far as rational numbers go. And neither one of those are going to add up to positive 2x. Not going to add up to positive 2x. So I'm unable to factor. So I'll just erase that because that didn't work. Will not factor. So how do I solve? Well, you remember from algebra class that you had a formula called the quadratic formula. And I'm going to sing this once. X equals the opposite of b plus or minus the square root of b squared minus 4ac all over 2a. But the thing is that's only good if you know what a, b, and c are. And you will know what a, b, and c are when you write this down. So this is not the formula, but this helps us know what a, b, and c are. A is the coefficient on the variable squared. B is the coefficient on the linear variable, and C is what we call the constant. The formula sitting right here, that piece right there, tells us what A, B, and C are. That piece in blue tells us what A, B, and C are. So for our problem, I'm going to write down in black here, A is 1. The coefficient on x squared, look up here, it's 1. You don't see it, but it's 1. B is 2, and C is -2. It absolutely matters that you include the sign. It's a -2. Signs matter. Every time I use the quadratic formula, I write it. So I said I was going to sing it one time. I'm going to sing it again. X equals the opposite B plus or minus the square root B squared minus 4AC all over 2A. If every time you use it, you write it, you'll remember it a lot better. So now I'm going to substitute in 1 for A, 2 for B, and -2 for C. Whenever I substitute anything in, I make sure that I substitute it with parentheses around it. B is squared. Minus 4 times A, I substitute with parentheses around it, times C, I substitute with parentheses around it. All over, matters all over, not part over, all over. 2 times A is 1. Order of operations says here, this square root is acting like a grouping symbol. So you need to do what's under the square root first. And under the square root, I see exponents. So by GEMS, one of the first things I'm going to do is I am going to square that to 4. Then I'm going to multiply on the same next step. I'm going to multiply these things, and that's going to change to either an addition symbol or a subtraction symbol based on what that product is right there. And so when I multiply 4 times 1 times -2, I get -8. But I'm subtracting a -8, so this is going to be +8. Then all over 2. So on this step, I did both my exponents and my multiplication on the same step. My next step, I'm going to continue with the grouping symbols. I'm going to find under the square root, it's 12. So I added basically. Sometimes you'll subtract there depending on how many signs you have. All over 2. Watch out for bad canceling. I don't want to cancel these because that's addition. That is the last step. Next step is to simplify my root. And square root of 12 is 2 root 3. My last step is to factor and cancel common factors if there is any. And I have one here. If I factor out a 2, it'll be -1 plus or minus the square root of 3, and that's over 2. Now I can cancel out that common factor. So what I have for an answer is -1 plus the square root of 3 and -1 minus the square root of 3. And if I type those into my calculator, guess what? This will be -2.732. This will be +0.32. These are my exact answers, my exact zeros. Let's go back to Desmos and prove it. If I type into Desmos -1 plus radical, which radical sits right under here, radical, I put it in the wrong place, plus radical 3, look at there. -1 minus radical 3, look at there. Those are those two intercepts right there. So that's proof positive. Now I might note that there's another way to get around solving this quadratic equation. We solved it by expanding, which is most students' natural way of solving. But we could also solve this by something called the square root method. Instead of isolating and getting equals 0 all the way through to use the quadratic formula, I can add 3 to both sides on this equation. And I can use my inverse operation and square root both sides. Now, one would think that the square root of x plus 1 squared would be x plus 1, but it's not. It's the absolute value of x plus 1. The square root of u squared is the absolute value of u. That has to be the case, kids, because if I just put x plus 1, I would only get one solution for x, and I already know there's 2. So I know that this should be the absolute value of x plus 1. Now I can use my absolute value equation techniques. This says x's distance from -1 is square root 3. So if I drew a picture of that, I'm measuring from -1, and I want to go square root 3 this way and square root 3 that way, right? So this would be -1 plus the square root of 3, and this over here would be -1 minus the square root of 3. Same 2 answers, okay? Or by option 2, I've got that either x plus 1 equals square root 3 or the opposite of x plus 1 equals square root 3. That gives me x equals -1 plus the square root of 3, or that gives me negative x is equal to -1 plus the square root of 3. X is equal to, wait. No, negative x is equal to, I don't want to go so fast here. Let's go slow, okay? Distribute the minus. Negative x is equal to 1 plus the square root of 3, or x is equal to -1 minus the square root of 3. Exact same 2 answers, right? Solving the absolute value equation either by using our distance idea or by option 2 that we talked about in class. We get the exact same answers. This is just your introduction to quadratic formula. We're going to talk about that a lot more next time, but I hope you took really good notes.